Hello everyone, today is a new day, new life, new beginning, and new lesson. Once again, I'm teacher Angie. Our lesson for today is about simplifying radical expression. So ano nga ba ang radical expression? A radical expression is an expression that uses a radical sign, square root. So we have here parts of radicals. So this is the radical sign, x is the radicand, and n is the index. By this, we can say that the nth root of x is equal to r. Means r raised to n is equal to x. In simplifying radicals, factor the radicand such that one of the two factors is a perfect number, perfect square, cube, etc. Extract the square root of the perfect number and retain the non-perfect factor inside the radical sign. In terms of the exponent of the variables, divide the exponent by the index and leave the remainder inside the radical. Simplify the following radical expression. Number 1, square root of 75. First, we need to find the factor of the radicand that one of the two factors is a perfect number. So we have square root of 25 times 3. And 25 can be written in exponential form. So we have now square root of 5 squared times 3. Next, extract the root of the perfect number. So how do we know if it is a perfect root? If the exponent and index are the same, then it is a perfect root. So 5 now is a perfect root. So we simply cancel radical sign and the exponent 2. And of course, the number that is not a perfect factor will remain inside the radical sign. Therefore, we have 5 square root of 3. Number 2, we have square root of 25. 25 is a perfect root. So we can write it in exponential form, 5 squared. Extract the root. If there's nothing written in your index, that means 2. So since the index is 2 and the exponent is 2, then it is a perfect square. Then our final answer is 5. Number 3, square root of 121, x to the 5th power, y to the 6th power. Of course, always start with factoring the number. So the factor of 121 is 11 times 11, or we can write it in exponential form, 11 squared. And then for our x, or variables, in terms of the exponent of the variables, divide the exponents by the index and leave the remainder inside the radical. So in here, since our index is 2, so 5 divided by 2 is not a perfect squared. So we remove 1. So we write 1 in here. And then 2 times 2 is 4. So 4 plus 1 is 5. The same through with y. So y divided by the index 2, the exponent outside, is equal to 3. So we have 3 inside. So next, we're going to cancel those perfect roots. Everything that has exponent 2, the same with our index 2. So we simply cancel 2, 2, 2. I will repeat. If you factored out this thing and use the close and open parentheses, the index must be outside. The number that is the same with the index must be the one you are going to cancel. So our final answer is 11 x squared y cubed square root of x. Let's check. The same. So 11 x squared y cubed square root of x. X is the non-perfect radicand. Next example, square root of 225x to the 10th power. So 225 can be 15 times 15, or we can write it in exponential form, 15 squared. And the factor for the exponent of the variable 10 divided by 2 is 5. Therefore, we have here x to the 5th power times 2 outside. Next, of course, we're going to cancel the perfect root by extracting it. So, cancel, cancel, cancel. Then, the final answer is 15 x to the 5th power. Number 5 is square root of 98, x cubed y to the 8th power. Next, we're going to factor 98. So we have 49 times 2. And 13 is not a perfect square since our index is 2. So 13 divided by 2 cannot be. So we will remove 1. So this is the one that we remove. And then 12 divided by 2 is 6. Therefore, we have 6 here. Okay, and the same through with is 8 divided by 2 is 4. Therefore, we have 4 here and the number of index outside. Next, we can write 49 in exponential form. So we have square root of 7 squared times 2, x to the 6th squared, x, y to the 4th squared. So we're going to cancel now the perfect root. So cancel radical sign, square, square, and square. And then we have a perfect root 7, x to the 6th power, and y to the 4th power. So we have 7, x to the 6th, y to the 4th, and then square root of those radicand that are not perfect. We have 2 and x. Therefore, the final answer is 7x to the 6th power, y to the 4th power, square root of 2x. Number 6, x squared times square root of 24x to the 9th power. First, we're going to find the factor of those radicand. So copy the terms outside the radical sign. So we have x squared, then square root of 4 times 6, x to the 4th squared, and then x. Next, of course, we can write 4 in exponential form. So we have x squared square root of 2 raised to 2 times 6x to the 4th squared, and then x. Then extract the root. So cancel 2, cancel 2. Then we have now x squared 2x to the 4th, and then square root of non-perfect squared. We have 6 and x. Next, multiply the terms outside. So 1 times 2 is 2. X squared times x to the 4th. Copy the base x and then add the exponent. 4 plus 2, 6. And then copy square root of 6. Number 7, square root of 50x to the 7th power. Then factor out the radicand. So we have 25 times 2, x cubed squared, and x. Next, write 25 in exponential form. So we have square root of 5 squared times 2, x cubed squared, and x. Then cancel out the perfect roots. So we have 2, 2. Therefore, we have the perfect squared 5x cubed. And then the non-perfect squared, we have 2 and x. Therefore, we have 5x cubed square root of 2x. Number 8, square root of 49 times m cubed minus n squared raised to the 15th power. So in this case, the same step. 49 can be factored out by 7 times 7 or 7 squared. And then m cubed minus n squared can be factored out with m cubed minus n squared. So 15 cannot be divided by 2, so minus 1, so we have 14. So 14 divided by 2, we have 7. So we have 7 here. And then the remainder 1 will be written outside. Next, we're going to extract the root. So perfect root cancelled, 2 and 2. Therefore, our final answer is 7 m cubed minus n squared raised to 7. Square root of the non-perfect root is m cubed minus n squared. Next, example number 9. 4x squared y squared times square root of 20x to the 6th power y to the 5th power. First, of course, we need to copy the number outside the radical sign. So we have 4x squared y squared, and then factor out the radicand. So we have square root of 4 times 6 x cubed squared y squared raised to the 2nd power y. Then write those perfect root in exponential form. So we have 4x squared y squared, square root of 2 squared times 6 x cubed squared y squared raised to the 2nd power y. And then extract the root. So cancel 2, and cancel 2. Bring out those perfect root. So we have now 4x squared y squared multiplied by the perfect root 2 x cubed and y squared, square root of the non-perfect root, we have 6y. Multiply the terms outside the radical sign. So we have 4 times 2 is 8, x squared times x cubed, copy the base x, and then add the exponent, 3 plus 2, 5. Y squared times y squared, copy the base y, and then add the exponent, 2 plus 2, we have 4. Then square root of 6y. Number 10, 5 all over 6, square root of 27x cubed. First, copy the term outside the radical sign, then factor out the radicand. So we have 5 all over 6, square root of 9 times 3, x to the 6th power raised to 2, and then the remainder, x. After that, write the exponential form of 9. So we have 5 all over 6, square root of 3 squared times 3 times x to the 6th power squared, and then x. Then, extract the root, cancel 2, cancel 2. So we have now 5, 6 times the perfect root, 3, x to the 6th power, and then the remainder, square root of 3x. 3 and 6 can be cancelled because 6 is the denominator of the fraction 5 all over 6. And 3 is a whole number. So 3 divided by 3 is 1. And 6 divided by 3 is 2. So we have now 5 halves times 1x to the 6th power square root of 3x. And our final answer, we have 5 times 1 is 5 all over 2 x to the 6th power square root of 3x. Number 11, square root of 27 x to the 5th power y to the 6th power. Factor out the radicand. So we have 9 times 3 x squared to the 2nd power times the remainder x y cubed squared. Then write in exponential form the perfect root 9. So we have 3 squared times 3 times x squared square x times x cubed squared. Then extract the root, cancel, cancel, and cancel. So we have now 3x squared y cubed, and of course the remainder or not perfect root, square root of 3x. Therefore, our final answer is 3x squared y cubed square root of 3x. Number 12, 5mn square root of 72mn to the 6th power. So copy first the term outside the radical sign. So we have 5mn and then factor out the radicand. So we have 5mn square root of 36 times 2m and then n cubed squared. Now, write in exponential form. So 5mn square root of 6 squared times 2m times n cubed squared. Then, extract the root, cancel, cancel. So we have now 5mn times the perfect root, 6, and cube. And the remainder, or not perfect root, we have 2m. So we have now 5mn times 6n cubed square root of 2m. Then multiply the terms outside the radical sign. We have 5 times 6 is 30, m, n times n cubed, copy the base n, and then add the exponent. 1 plus 3 is 4. And then, of course, our radical sign, square root of 2m. Therefore, our final answer is 30m n to the 4th power square root of 2m. Number 13, we have x, y squared is square root of 12, x to the 7th power, and y to the 6th power. First, we need to copy the terms outside the radical sign and then factor out the radicand. So we have now x, y squared is square root of 4 times 3 times x cubed squared, and the remainder x times y cubed squared. Then we're going to write 4 in exponential form. So we have xy squared is square root of 2 squared times 3, x cubed squared, x, y cubed squared. Then extract the roots. So we're going to cancel the exponent 2, 2, and 2. Now we have xy squared multiplied by our perfect roots. We have 2, x cubed, and y cubed. And the non-perfect root will be remain inside the radical sign. So we have square root of 3x. Next, we're going to multiply now the terms outside the radical sign. So we have 2 times 1, 2, x times x cubed, copy the base x, and then add the exponent. 1 plus 3 is equal to 4. Y squared times y cubed, copy the base y, and then add the exponent. 3 plus 2, we have 5. And then copy the remainder, or not perfect root, square root of 3x. Therefore, our final answer is 2x to the 4th power, y to the 5th power, square root of 3x. Number 14, square root of 32, x to the 15th power, and y to the 10th power. Of course, first, we need to factor out the radicand. So we have 16 times 2, x to the 7th power squared, and the remainder x, and then y to the 5th power, remainder 2. Next, write in exponential form. So we have 4 squared times 2, 7 squared x, y 5th squared. Then, extract the root. Cancel ang 2, cancel ang 2, cancel ang 2. So our perfect roots are 4, x to the 7th power, y to the 5th power. And for our non-perfect root, we have 2 and x. Therefore, we have 4, x to the 7th power, y to the 5th power, square root of 2x. Number 15, we have square root of x minus 7 raised to the 10th power. So in here, this is very easy. We just think of the factor of the exponent outside the radicand. So the index is 2, so 10 divided by 2 is 5. Therefore, we have this. Square root of x minus 7 to the 5th power raised to 2. Then, extract the root. So just cancel 2 and the radical sign. Therefore, our final answer is x minus 7 to the 5th power. Last but not the least, number 16, bonus. So we have 6m squared n, square root of 36m n to the 6th power. First, we're going to copy the terms outside the radical sign and then factor out the radicand. So we have 6m squared n, square root of 6 squared m, n cubed squared. Extract the root. So cancel out squared, squared. So we have now 6m squared n times the perfect root, 6 n cubed, and the non-perfect root, square root of m. So we have 6 times 6, 36, m squared, just copy because there's no m here. And then n times n cubed, we have n, then add the exponent, 3 plus 1, 4. And then our perfect radicand, we have square root of m. Therefore, our final answer is 36m squared n to the 4th power square root of m. Okay, so that's all. If you have any question, just drop your questions on the comments section. That's all for today. I hope you learned something from this video. Please do watch, like, share, and subscribe. Thanks. Keep safe and God bless us all.